Here we're going to start dealing with linear inequalities in one variable, and pretty much this is first page. You're just going to want to kind of just take a look over it. Take me in class. You can obviously print this out. If not, just screenshot it. I'll try to scroll down here where you can kind of see a little bit of everything. You can't really see completely everything, but let's just kind of look over things since we're dealing with linear inequalities in one variable. Okay, notice how things are kind of written here. Now, what I try to tell students is, especially when reading these, first off, always read from the variable. Okay, so notice like this one right here, how we've got the variable x right here. So this one you can read as x is greater than a, x is less than b. Notice this is not or equal to. We don't have the little line underneath the inequality symbol. Okay, but I do want you to also realize that since there is not an inequality symbol, we are also going to be using the parentheses as well. When we do have any sort of equality happening, we want to make sure that we are using the brackets. Okay, remember these right here are not coordinate points. It is one of those places where we've had to utilize the same notation in different aspects, so context is really key. What I always try to tell students is whenever you start graphing these, if you'll notice here, because a lot of the things you're going to be asked for, you're going to be asked to give this in interval notation like that. If you'll notice that if you'll do a quick sketch of the graph, notice here, regardless of what your answer is, your graph is very similar to whatever you're going to have right here as far as your interval notation. So if you graph first, usually the question is going to ask for interval notation first, but if you give yourself a quick sketch, you're killing two birds with one stone. Notice here you can also, some questions will utilize both. This one has a parenthesis, but then it also has a bracket, which we can see right here. Okay, these cancellation properties, these are pretty straightforward and simple once you start reading them very carefully. I was just reading through these, reminding yourself of them. The big one that you need to kind of remember is going to be this guy right here. Notice it says if A is less than B, okay, and D is less than 0, that means D is negative. Okay, when you multiply D to both sides, okay, notice right here what it says, you end up flipping the inequality. Okay, you'll see that through some examples that we're going to go ahead and kind of work. Okay, so just kind of like I said, just kind of go through this page, kind of look at it, screenshot it, remember it. Like I said, always kind of, if you go listen to if you follow the variable, it makes it a lot easier to read. Notice how this one right here, okay, this actually says x is greater than a. Okay, this would mean the same thing. Okay, if you wrote it like that, x is greater than a. Okay, so if you follow that variable, it's just going to make it a lot easier for you in the long run. Let's go down here and let's do an example real quick. I'll work this one. Let me give us a little bit of some room here. Okay, I'll do this example for us. First thing you want to do is you're going to want to go and clean it up, obviously. Okay, so we're going to go and start the cleanup process very, very carefully, very intentionally. Okay, always remember, let's go and just kind of make some notation here. Always when going off to the left, this is going to be going to negative infinity. This is always going to positive infinity. All numbers get greater as they go to the right. All numbers get smaller as they go to the left. Okay, so like I said, let's come in here and let's go ahead and start the distribution. Notice we have a negative here. We need to go ahead and make sure to distribute that in there as well. So we've got 5 minus 2x, a negative make a positive, and that's going to become plus 6, is less than or equal to, well, that's going to be a negative 1 plus x. Okay, so far we're looking pretty good here. Let's continue this on and let's go ahead and combine like terms wherever we can. And notice here we've got this 5 and a 6. This is going to give us a negative 2x, okay, plus 11. And then I've got this right here. Notice I've got this negative 1. Nothing needs to be simplified over here, so I got negative 1 plus x. Well, let's come over here and how about we go ahead and add 2x to both sides. Okay, that's going to reduce this out over here. Okay, and let's go and add 1 to both sides. Okay, that'll reduce that there. Notice we can go and rewrite this. We're going to have a 12 here, less than or equal to, and then we're going to have this 3x. Let's divide off our 3, And then notice 12 divided by 3 is going to give us a 4 is less than or equal to this x, which we can also flip around and say x is less than, let me rewrite that. I did that wrong there. Gotta follow. Keep that alligator mouse keep the alligator mouse mouth facing toward that variable. X is still greater than or equal to x. So it doesn't really matter where you put everything on this. So notice, remember what I said, if you put like say a 0 right here, we can go 1, 2, 3, 4. Put a 4 right here. Well, let's realize, remember, we've got this or equal to. This is also greater than, which means it's going to be going in this direction right here. And since we're using or equal to, we can put a bracket facing in that direction. We would close this off with a parenthesis because you can never obviously equal infinity. So here would be our graph, but what would our interval notation be? Well, remember, I said the graph mimics the interval notation. So you come here and just put this down, put a 4, comma, put your infinity symbol, and there. And that would be how you would do your inequality for this one. I'll leave that next one for you to work, but remember, one way to make it easier is go ahead and multiply everything by at least, literally, like you could look at the least common denominator of this and notice it would be 4. So if we multiplied everything by 4 on this next one here, you'd notice that would reduce out your denominators and you wouldn't have to deal with them anymore. So that's a good one to kind of practice on your own. So let's look at solving double linear equalities. Okay, taking a look at this one real quick. First off, we notice that, look, we've got an open interval here and we got a closed. That means I'm going to have a parenthesis and I'm going to have a bracket utilized in this one. Another thing I want you to realize here is, let me get out the red marker here, is notice here that right here and right here, okay, everything, the little alligator mouth is facing this way, but everything is pointing, the little mouth is pointing this direction and it's pointing that direction. Well, that's a less than symbol. When you have a less than, okay, when you have less than, okay, that means you're always going to have an intersection. You'll see that shortly, what that looks like. If you have greater than, okay, you're going to have a union. Let's solve this one. Let me get this out of here. Let me kind of clean that up a little bit. We'll solve this very quickly. Solve from the middle. Do it the same way. So notice I've got this 3 here. So how about we subtract off 3? And we're going to subtract off 3. Remember, we're working from the inside out. So as we start to do this, notice how this is going to work here. So this is going to be a negative 4. This cancels. Keep that. You're going to have a negative 2x. And then notice 5 minus 3. That's just going to give us 2. Now we're going to take this negative 2 and let's realize we're going to be dividing by negative 2. Remember that you're dividing by that negative 2. Okay, that would be the same thing as multiplying, okay, by negative 1/2. The reason I'm saying that is since you're dividing or multiplying by a negative, we're going to end up having to flip these signs. Okay, so let's work our way in this direction. Notice a negative and a negative make a positive. That's going to give us a 2. We're going to flip these signs around. That's just going to leave us with an x there. Flip this sign around as well. A negative and a positive make a negative. Okay? And then that's just going to give us a negative 1. Realize, though, that this is backwards. Notice we have negative on the right-hand side, a positive on the left-hand side. So this can be rewritten like this. Okay? So negative 1, x, and 2. Reading from the interval. Notice our number is going to be x is greater than or equal to negative 1 and x is less than 2. Well, look at how this works. Let's just go and just put a little 0 down here. I'm not really going to be too concerned about where I put my negative 1 and everything right now. So notice if I just put a negative 1 right here and let's just say I put a 2 right here. Well, x is greater than or equal to. Well, I know that's going to be facing in that direction. X is less than 2. That's facing in that direction. And so there, just like I stated, you ended up having this intersection here. But also notice my graph also mimics, okay, not mimics, it literally shows you what the interval notation is. So my interval notation is negative 1 to 2, okay? Which means for this statement to still stay true, Okay, I can have -1. That's a-okay, because notice if I put a -1 here, well, is -1 greater than or equal to -1? Yeah, that or equal sign takes care of that. Is -1 less than 2? Yes, that works out just fine. Also, notice if I pick another endpoint over here, say I just pick 2. Here's where the problem would come. If I pick exactly at 2, well, notice what's going to happen. Is 2 greater than or equal to -1? Yes, it is. But is 2 less than 2? No, it is not. That's how come that parenthesis right there says you can get infinitely close to that 2, but you can never equal the 2. And so that's exactly what that's saying. So 1.9, that would work. 1.999, that would work as well. But you can never exactly equal that 2. Let's do another one here. Remembering, okay, first off, before I move down to the next part, remember this right here. Take a note. Less thans will always be an intersection. This was a less than. We got an intersection. A greater than will be a union. Okay? If you remember that, it's going to help out a whole lot. Notice what I just said is kind of mimicked right here, but it does say that. When you have the absolute value of x is less than a, it's the same thing as writing it this way like this. Because notice, this less than symbol created that intersection. If the absolute value of x is greater than a, then you have two different combined with an or. Or means union. Okay? Well, what does this mean? Let me look through here and see if I can't find one. Okay, here we go. Let's look at this one right here. Kind of make us a little bit of a room here. Like I said, leaving you some of these other ones for some examples, and I'll also give you some homework examples in a little bit. But notice this one right here is in standard form right now. This is the way you've got to get these absolute values first. Just like when there was an equality, before you can solve them, you have to get them in standard form. So notice what I have here is I have two inequalities I need to solve. I have this 4 minus 2x is greater than 6. But I also have another one. I have 4 minus 2x, but then I got this negative 6, because remember we're dealing with an absolute value symbol. But the moment you create this negative, you've got to flip the sign. Okay? Now as I stated, since we're dealing with a greater than, we're going to get a union. Also, notice we're dealing with a greater than, not a greater than or equal to. So we're going to get a union. Okay, we're going to get a union graph, and I'm going to show you how to get a union for your interval notation. Let's go through here. Let's do the solving. Okay, solve it like normal. Come in here, subtract 4 from both sides. Okay, you're going to get negative 2x is greater than, well, this is just going to be a 2. Let's divide off the negative 2. Notice this cancels out here, or reduces out, to x, but since we divided by a negative, okay, we've got to flip the sign, and then notice right here, well, what are we going to get? We're going to get a negative 1. Same thing. Negative 4 here, negative 4 here, negative 2x, keep everything the same. Okay, here we're going to get a negative 10, because remember, negative 6 minus 4, okay, that's going to be a negative 10. You're not multiplying or dividing right here. Okay, divide off the negative 2. Okay, you get x, flip the sign, and then negative and negative make a positive. Okay, and then you're going to get a 5. Well, let's see what this looks like. This literally says x is less than negative 1. If you literally just follow along with what this says, so notice this says x is less than, x is greater than. Okay, what does that mean? Well, come over here and let's just give myself a negative 1 right about here. And this is saying x is less than that. Okay, well, less than is always in this direction. Well, then notice what it says. Okay, x is greater than 5. If I just put a 5 right here, I can take this and go, well, x is greater than 5. Well, look at what happened here. I have this really weird gap in here. That's fine. We're going to make a union. This is exactly what we planned on. Notice we can close this off on both sides. Okay. Notice here also we're dealing with parentheses because these are open intervals. So I can put a parenthesis there and a parenthesis there. There's your graph. Okay. Really, you'd want to go ahead and do this because you're probably not going to be using highlighters. Okay. But notice, if we continue on with this, when we want to do the interval notation, always from left, okay, to right, because that's how we read. We always come from negative infinity, and we're always going toward positive infinity. So we can say, hey, how about we go to from a negative infinity up to -1. We cannot include it. Put a union symbol. Then we're going to start at 5 and go on to positive infinity. And there is your interval notation. And there is also, like I stated, that's a union graph. I knew I was going to have a union graph because of the greater than symbol. Okay, even with all the flipping of signs, I didn't care. This guy right here said I was going to have a union. So it all worked out. All right, move on. I'll do some homework examples.